Welcome to the paper discussion on part test 4. Compressibility of water is 4.5 into 10 power minus 10. Water subject to the pressure of 2 into 10 power 7 Newton per meter square. Compressibility is 1 by bulk modulus, which is excess pressure by volumetric strain. So simplifying this, we end up getting delta P into V upon delta V is equal to 1 by compressibility. We are being asked to find the change decrease in volume with a minus sign, of course. So I'm just finding the magnitude here. Delta V will be equal to delta P into V into sigma. So you just multiply the whole thing. The excess pressure is 2 into 10 power 7. Initial volume is 1000 cc. 1 liter is 1000 cc and compressibility is 4.5 into 10 power minus 10. This ends up becoming 9, which is right answer. Moving on. Particle executes SHM of amplitude 5 centimeters and time period 3 seconds. So time period is 2 pi by omega, which is 3 seconds. Pi is taken as 3 here. So we will end up getting omega is 2. Now let's start simplifying using particles velocity. I will default it as a sine of some phase. Phi can be written as omega t plus phi naught, which is different. I'm going to solve it later. But x will be a sine phi. Velocity will be defined as omega a cos of the same phase. And acceleration will be minus omega square times a sine of the same phase. Amplitude 5 is and the particle is at 4. When x is 4, amplitude is 5, the phase is going to become 53 degrees. It's either 53 or 137 or 127. But we are going to take one of those both. And cos of the same value is going to be 3 by 5. So I'm going to substitute velocity. Omega will be 2, amplitude is 5 into 3 by 5 will be the answer, which is 6 centimeters per second. Moving on, a 10 centimeter long wire from a liquid surface having surface tension 40. Force required other than its weight. Force due to surface tension will be 2 SL. 2 into 40 dynes into length is 10 centimeters. So this is going to be, if you observe, it is 800 dynes, which is 800 into 10 power minus 5 newtons, which is 8 millinewton. You can just see 4 and double of the answer is going to be there. The only option which has 8 is here, which is the right answer. Alright, moving on. A uniform rod of mass 3m and length 12. Mass 3m and length 12 is placed here. Just assume the rod is like this, 3m and 12. This is AB. Another mass of 2m is going to come and hit it at exactly in the midpoint with speed 2u. And this length is going to be L. So first equation I'm going to write is after collision I'm going to take this body to go back with omega, and this is going back with v, rotating with omega and back with v. So first equation E is equal to 1 will be speed of separation by speed of approach. Speed of separation will be the velocity of this point, which is omega L, plus v, because they both are separating in opposite directions, by 2u. From this I'll end up getting omega L plus v is equal to 2u. This is my first equation. Now second equation ke liye I will use conservation of angular momentum, because we can't conserve momentum, we can only conserve angular momentum about the hinge. Excuse me. Initial angular momentum is 2m into 2u into length, which is 4 mul. And final angular momentum will be I omega of the rod, which is 3m into 2l whole square by 3, ml square by 3 in times omega, minus 2m into v into l. These both will be equal. This 3m is gone. So I will end up getting a simple equation where I get 4 mul is equal to 4m omega l square minus mvl, 2mvl. So इससे क्या है, cancelling 2ml everywhere, I will end up getting 2u is equal to 2 omega L minus V. This is my second equation. And the first equation is omega L plus V is equal to 2u. So I just add both of them. V is going to get cancelled. I will get 4u is equal to 3 omega L, which I get omega L is equal to 4u by 3 and V is equal to 2u by 3. Now question asks, what is the final velocity, speed of the particle after impact? Speed of the particle is 2u by 3. Time period of a ring of radius r suspended from a peg and a time of a thin rod of L suspended from the one end are the same. Time period for this kind of compound pendulums is default given by 2 pi root I by mg d, where I is the moment of inertia about the axis and d is the distance between the axis and the center of mass. So first case, it's a radius of a ring at the edge. So d is going to be r and I is going to be mr square plus mr square, which gives 2mr square. For a rod, moment of inertia is going to be ml square by 3 and the distance is going to be L by 2. So just substitute both of them. 2 pi is going to get cancelled. It's I by d, I1 by d1 is to I2 by d2, which is root of, if they both are equal, which is 2mr square upon r, mgr is going to be equal to ml square by 3 upon m into g into L by 2. Gone, 1 LL gone, same way gone, 1 RR gone. This G is going to get cross cancelled. So you end up getting root 2R is equal to root 2L by 3, or R is equal to L by 3, which implies L is equal to 3R. Angular speed of the second hand is 2 pi by time period, which is 2 pi upon 60, pi by 30. It's a very easy question. You should not miss this. Water drop of this area is squeezed between two glass plates of thickness 40 centimeters square, of area 40 centimeters square. So thickness is going to become 0.05 upon 40 centimeters, which is 1 by 800 centimeters. So to balance the force required is acting along this direction of the thickness. So the force into T will be equal to 2 times surface tension into area, because it's having two plates. Force is going to be 2T area by thickness, which is 2 into surface tension, which is 70 dynes, into area, which is 40 centimeters square, upon 1 by 800, which is multiplying 800 here. So you end up getting 10 power 5 into 10 power 4 into around 450 into 10 power 4 dynes, which is approximately 45 newtons. Two wires having same material are stretched by same force. The diameters are in the ratio of 1:2. Diameters are in the ratio of 1:3, which means area is in the ratio of 1:9. The ratio of strain energy per unit volume for these two wires when they are stretched is same force as stretch हुआ. So force is same. Stress will be in the ratio of 9:1 because area is in this ratio. And energy stored is always defined as half into stress square by Young's modulus. So I'll get 9 square is to 1 square as the answer, which is 81:1. Next. In this question, velocity of the liquid coming out of the hole here will be, generally velocity will be defined as 2 times G of rho 1 H1 plus rho 2 H2. It's a weighted average of rows, weighted average sum of rows, row heights by the density of the fluid which is coming out. Substitute the values, so you end up getting 2G times rho 1 is rho into 2H plus 2 rho into H upon 2 rho. Here 2 rho comes twice here, so you just cancel it up, you end up getting root 4GH, which is 2 times root GH. Alright, now here a box, same way. This velocity here is given as V0. Let's take the side here to be A. If that is A, this is going to be A by root 2. So V final is going to be root of 2G into A by root 2. Well, V0 is equal to root 2GA. Linking both of them, I'll end up getting root of 2GA by 2 power 1 by 4, which is V0 upon 2 power 1 by 4. Solid cylinder of mass M is rotating. So this is a mass M. It is connected by 2 threads, not 1 but 2 threads of mass M each. So tension is going to be T above and acceleration is going to be same, downwards. Let's take downwards acceleration. This is going to rotate with alpha. The first equation I will write is rolling relation. We will directly get acceleration is equal to alpha into r. Yes, this is the first equation. Second equation I am going to write is for Newton's law for these bodies. I will write 2mg minus 2t is equal to 2m into a. This is my second equation. And third equation is torque equation for this solid cylinder. Torque is equal to I alpha, which is T into R will be equal to mr square by 2 into alpha. So alpha I can write as A by R and I can simplify. From this I will end up getting 2T, sorry, because there is 2T acting. 2T is equal to M into A upon 2. Our tension is MA upon 4. Once you find out acceleration, I think you're sorted. 2t is ma by 2, substitute here, I will end up getting acceleration will be equal to 4 mg upon 4 mg plus capital M, 4m plus capital M. And tension will be ma by 4, which is mmg by 4m plus capital M, which is option D. You just have to write those three equations. One is rolling relation, one is Newton's laws of motion, one is torque equation. This is how you solve this rotation problems. Now, a particle is oscillating harmonically at t is equal to t by 12. T by 12 means one time period is 360 degrees. So, this t by 12 makes it 30 degrees, and remember, phase is everything. Kinetic energy will be proportional to cos square of the phase because it is linked with velocity, and potential energy is linked with sine square of the phase. Cos square of 30 will give you 3 by 4 times some value, and this will give 1 by 4 some of the value. The ratio of this both will be 3 by 1. Two raindrops are falling with terminal velocity. Terminal velocity is proportional to r square. So V2 by V1 will be equal to capital R square upon r square. Or we end up getting V2 is equal to capital R square by small r square into V1, which is V capital R square by small r square. A force constant of an oscillating pendulum is K is generally defined by m omega square. So from that you can say directly proportional to mass of the bob. There's nothing much to say there. Which is why that mass also gets cancelled, technically speaking. Now, linear momentum question. What will be the angular velocity? So let's just solve this problem about this point. About center of mass, it will rotate. So this body impact is given as this. Angular momentum will be defined by mv into L upon 2, L by 2. This is only going to be equal to I omega. I of the system is going to be ml square by 2. How did you get this? Each of them is L by 2 away. Each of them has moment of inertia of ml square by 4. The total will be ml square by 2. Simplifying this, I end up getting omega is equal to V upon L. Steel is used for construction of bridges. Yes, of course, we've seen it. Steel is more elastic and it is elastic limit is high, which is also true, and it is also a good reason why steel bridges are made, because they will be more flexible. Hence, answer is A again. Which of the following represents the difference between total energy and potential energy? What is difference between total energy minus potential energy? It is going to be kinetic energy of a particle executing versus its distance from mean position. We know at mean position, kinetic energy is maximum. There's only one, and it follows this smooth curve, which is this. Okay, a particle executing SHM has velocity v1 at x1 and v2 at x2. The mean position, its frequencies, we have to find out omega. Or frequency is omega upon 2 pi. So we can use this equation where x by a whole square plus v by omega a whole square is equal to 1. We can apply, we can just remove a and throw it to the other side. We can simply say x square plus v by omega whole square is constant. So I will write x1 square plus v1 square by omega square will be equal to x2 square plus v2 square by omega square. Taking v2 to the other side, x1 to this side, I will end up getting x1 square minus x2 square is equal to v2 square minus v1 square by omega square. Omega is root over v2 square minus v1 square by x1 square minus x2 square. And omega by 2 pi is the answer. v2 minus v1 by x1 minus x2 is the right answer. Moving on. Power is generally defined as F dot V. In rotation, we can write it as torque dot omega. Is defined by P. Torque is basically I alpha. So omega I alpha into omega is equal to power. Omega is P by I alpha, which is P into I alpha power minus 1. Now ideal fluid, this is based on Bernoulli's principle. He is asking kinetic energy per unit volume, which is defined as half rho V square. We know one thing, area is more, which means by equation of continuity, area of y is greater than area of x, which implies V of y will be less than V of x. By applying that here, I can also say half rho Vy square will be less than half rho Vx square. So kinetic energy at this x is k1 and y is k2 is given. So k1 is greater than k2 is the right answer. Alright, a rotating body at 20 radians per second is acted upon by constant torque, which produces deceleration of 2. At what time will the body have kinetic energy as the initial value? So from 20 it is going to reduce with alpha equal to minus 2 till a point it becomes 0, then becomes negative. When will kinetic energy be same? When it has same mod of omega again, which means when the final value is minus 20 radians per second. So alpha is minus 2, delta omega will be 40, minus 40. Time taken will be minus 40 by minus 2, which is 20 seconds. Yeah, simple harmonic motion में one is 10 sin 3 pi by 4 plus 3 pi t plus pi by 4, and second one, if you simplify this, I'll divide by 2 inside and multiply by 2 outside. I'll end up getting 10 sin 3 pi by t by 2 into cos 60 plus sin 60 into cos 3 pi t, which will end up becoming 10 sin 3 pi t, not by 2, this is not there, 3 pi t plus 60 degrees. So both of them are having same 10 as the amplitude. The ratio of amplitude is going to be 1:1. The phase difference is इसका 45 degrees है, इसका 60 degrees है. Phase difference is 15 degrees. Alright, and time taken also you can say omega is 3 pi. You can just play around with this question. Moving on. For rolling a shell, the ratio of rotational kinetic energy to total kinetic energy. Rotational kinetic energy is half I omega square. Total kinetic energy is half I omega square plus half mv square, which will in short become half mv square into 1 plus I by mr square. There's this factor which keeps popping up everywhere. Linking both of them, I end up getting the answer as just give me one moment. Linking both of them, I get the answer as iska moment of inertia will be 2 by 3 times I by mr square is going to be 2 by 3. So I'll get an answer as 2 by 3 by 1 plus 2 by 3, which is 2 upon 5. So value of x will be 2. And in this question, each mass is 3. Matlab, if you just simplify the question, acceleration downward will be g by 3, because only one of the 3 masses is pushing it down. The other two are just staying up. It's a tension आएगा 2 mg upon 3. Tension will end up becoming 20 newtons. You apply Newton's laws and check for tension as 20 newtons. The longitudinal strain. Strain is defined as stress upon Young's modulus. Stress is force by area, which is force upon AY. Force is 20 newtons. Area is given as 0.005 centimeter square, which is 5 into 10 to the power minus 7. Into Young's modulus is 2 into 10 to the power 11. So simplifying both, I'll end up getting 2 into 10 to the power minus 4 as the answer. So option here is going to be 2. The final answer, disk of mass this and radius is rotating with angular velocity omega. Its axis perpendicular plane. An identical disk is kept gently on it. The same axis, the energy dissipated so that both disks continue to rotate together. So initially mass, it's like initially it has I and omega. Finally it is going to double moment of inertia. So omega will become omega naught by 2. And kinetic energy will also become half of initial. Because that's generally the logic, when mass doubles and velocity becomes half, kinetic energy becomes half. So the loss in energy is basically half of kinetic energy initial, which is half times I initial, which is mr square by 2, 5 into 2 square by 2 into omega square, 10 square, iska half. So this is 500 by 2, which is going to be 250 joules. That is the right answer. So that's all.